we have another 3 words to add to our vocabulary today as we continue to learn more about our atmosphere. So our first word today is going to be the word wind. So wind is the movement of air from high pressure areas. Wind is the movement of air from high pressure areas to low pressure areas. So wind is the movement of air from high pressure areas to low pressure areas. So this week, we're going to be looking at the concept of air pressure because yes, air does take up space, so air has pressure as well as something called density. All right, so in the details box, well, we're going to write about wind. What is it that actually causes wind, that causes air to move? It has to do by the heat from the sun and the fact that that heat is not even. So wind is going to be caused by it's caused by uneven heating from the sun. And as we're going to see this week, not all areas of Earth get the same amount of energy from the sun because we have lots of different places on Earth. Everything is not exactly the same. So for our example of wind, draw what you think of when you think of wind. I'm going to draw an object being pushed along by the wind. I'm thinking of like a kite. You could also do a sailboat. So I'm going to draw here in the wind a kite with its little tail on it and the wind blowing along. And the key thing we're going to see is that air always moves from areas of high to low pressure. And that's going to be what creates the wind. So again, I'm drawing a kite in the wind. You could draw a sailboat in the wind. So wind is the movement of air from high pressure areas to low pressure areas. And we're going to see this week that that's caused by uneven heating from the sun. So our next word is going to better help us understand wind. So our second word is a word density. And again, density is going to better help us understand how air has pressure and how that's going to cause wind. So density is a measure. It's a measurement, just like volume or area. Density is a measure of how tightly packed. Density is a measure of how tightly packed, atoms are. So it's a measure of how tightly packed atoms are, or, and this gets a little more mathematical, or density is the amount of mass in a given space, also known as volume. So density is a measure of how tightly packed atoms are, or the amount of mass in a given space, also known as volume. So what we're going to see here for density is that this helps us see and understand why things like air and water are going to move. So in the details, I'm going to write density is the reason air and water rise and sink. So understanding density is going to help us understand why warm air rises and cold air sinks, or why warm water rises and cold water sinks. So we're going to see that that's part of this idea called density. So for my example, I'm going to draw a sketch of what density is telling us, right? It's telling us how tightly packed the atoms are or the amount of mass in a given space. So I'm going to draw two different boxes or two different chambers here, right? So two different boxes. And I'm going to label one of them low density, and I'm going to label the other one high density. And so because density is about how tightly packed the atoms are, if something's low density, its atoms are going to be pretty spread out. They're not going to be very tightly packed. Whereas something that's high density, and actually I'm going to go back and just color these in so you can see them better. In high density, my atoms are going to be much closer, tightly packed together, because density tells us how tightly packed atoms are, or there's a lot of mass in this space, right? They're the same space, but high density has a lot more objects or atoms in a space compared to low density where you don't have as many. So that is our second word, density, and we're going to see densities related to air, it's related to water, it's technically related to any kind of substance because everything we know has mass and takes up space, so that means we can figure out its density. All right, our last word today is going to be a little bit weirder. It's going to be a little more technical, and it's because this next word gets the name from the Italian scientist who, came up with this idea many years ago. So our last word today is something called the Coriolis Effect. And the Coriolis Effect is a force, and it's a force caused by Earth's rotation. Because remember, Earth is turning. So the Coriolis effect is a force caused by Earth's rotation. So it's a force caused by Earth's rotation that influences the direction of wind and ocean currents. So the Coriolis effect is a force caused by Earth's rotation that influences the direction of wind and ocean currents. And so what this does, because the fact that Earth is rotating or spinning, although it's doing it, pretty slow, it's going to cause wind and water to curve. So I'm going to write here in the details, wind/water curves, and then I'm going to kind of put a little thing here because it depends on where you are. It curves right in northern hemisphere, and it curves left in the southern hemisphere. And hopefully you guys all know that hemisphere is just half the Earth, right? Hemi means half of a sphere. So I'm going to draw a picture of that here. I'm going to draw my, Earth here. And like we said, if we divide the Earth in half at something we call the equator, then we have a north and a south, right? A north hemisphere and a southern hemisphere. So what this is telling us is because Earth is spinning in the north, we're going to get winds and ocean currents that curve to the right, and in the south, we're going to get winds and ocean currents that curve leftward. But this explains why we see curved patterns or sometimes even circular patterns in wind and water. So this week we're going to be looking at wind, understanding why it happens because of density, and we're also going to see the Coriolis effect has an effect on wind and is what causes the large wind patterns that we see moving across our planet.